Welcome to the Explainer. All right, today we're tackling a theory that sounds like it's straight out of a science fiction movie, but it's being taken very seriously by cosmologists. It's an idea that could completely rewrite how we think about the Big Bang and even our own existence.
So let's just get right to it. The big question here is, could our entire, massive, expanding universe actually be tucked away inside the event horizon of a black hole? You know, the point of no return? And is that black hole just floating around in some other, even bigger parent universe? Sounds crazy, right? But as you're about to see, this wild idea might just be the key to solving some of the biggest mysteries in all of physics.
So you're probably wondering, why on earth would scientists even entertain an idea this out there? Well, it's because our current standard model of the universe, it's got some pretty serious cracks in its foundation.
Our best theory of the cosmos, the one that's been wildly successful for decades, is called lambda CDM. The lambda is for dark energy, and the CDM is for cold dark matter. Think of it as the official rule book for the universe. And it works great, except for these two huge, nagging questions that just won't go away. They hint that we're missing a really big piece of the puzzle.
Okay, problem number one. It's called the fine-tuning problem, and it is a huge headache for physicists. Here's the deal. Our theories of quantum physics predict that even empty space should be buzzing with a certain amount of energy. But when we go out and actually measure it, the number we get is wildly, ridiculously different.
And this is where it gets absolutely nuts. Just how different are we talking? Well, for our theories to match what we actually see, we have to assume a level of precision that is just impossible. It's like 1 part in 10 to the 120th power. That's a 1 followed by 120 zeros. I mean, to call this a small error is an understatement. It's literally the biggest mismatch in the entire history of physics.
And then there's mystery number 2, the coincidence problem. Think about it like this. Way back in the early universe, regular matter and dark matter were the big bosses. And way in the future, dark energy will run the whole show. But right now, right where we live, the amount of matter and the amount of dark energy are, weirdly, about the same. It's a tiny, special sliver of cosmic time. It just feels a little too perfect, you know? A little too coincidental.
So, with these massive problems just staring us in the face, a new idea has entered the ring. Let's really dig into this black hole universe hypothesis and see how it claims to fix all of this.
So here's the core idea. Forget the Big Bang being the absolute beginning from a single, infinitely dense point. That's the old story. The new idea is that our Big Bang was actually a big bounce, a rebound that happened deep inside an already existing black hole, in some other universe.
And this is the real kicker. That mysterious dark energy, what scientists call the cosmological constant, it's not some magic number that's been perfectly fine-tuned and baked into the fabric of reality. Nope. In this model, its value is just a hand-me-down property, something our universe inherited from its parent black hole. And just like that, poof, the fine-tuning problem just vanishes. It's not a problem anymore.
Okay, so this model is pretty slick, right? But it gets even better. It doesn't just solve that one big problem. It starts knocking down other long-standing paradoxes in physics like a set of dominoes.
All right, check this one out. It's called the bag of gold paradox, and it's a real head-scratcher. Calculations show that the total stuff inside our universe is about 29 times more massive than the parent black hole that supposedly contains it. How do you fit 29 pounds of stuff into a bag that can only hold 1 pound? It seems impossible.
Well, the answer comes from a really weird loophole in Einstein's general relativity. Think of the black hole's event horizon, its outer edge, as the opening of a bag. The size of that opening is fixed, but the inside of the bag, the actual volume of space-time within, that can stretch and grow, basically forever, completely independent of the opening. So you can have a universe with tons of mass on the inside, no problem.
Okay, next up, what happens at the very center of a black hole? Usually we think of an infinite crunch, what's called a singularity. But this theory says, not so fast. It uses a modified version of gravity where, at insane densities, the natural spin of all the tiny particles creates a powerful repulsive force. It's like hitting a quantum trampoline. Instead of collapsing forever, matter hits this trampoline and bounces back outward, creating a brand new, expanding universe. Our universe.
So, this all sounds like a great story, right? But is that all it is? This is where things get really exciting. This model actually makes predictions we can go out and test. And scientists right now are digging through data, looking for clues that could prove it right.
And here's Exhibit A.
The James Webb Space Telescope is finding these baby supermassive black holes in the super early universe that are just way too big, way too soon. According to the standard Big Bang, there just wasn't enough time for them to grow that large. But in a bounce scenario, they could just be leftovers, relics from the universe that came before.
But it gets even weirder. When you map out where these ancient massive objects are, they're not scattered around randomly. They actually seem to line up across the sky. See that? They form a sort of axis of evil, as some astronomers call it. It's like the entire cosmos has a preferred direction, which is not something we expected to see.
So, what's going on? Well, the theory has an elegant answer for that too. It says this axis is basically a fossil, a leftover from our parent black hole. If that parent black hole was spinning, it would have literally twisted and dragged the fabric of space-time as our universe was born. That process would have stamped a spin axis onto our entire cosmos, one we can still detect today.
So, let's step back for a second. What's the verdict? The black hole universe idea isn't proven. Not yet. But wow, is it compelling. It's like one of those master keys that suddenly seems to unlock a whole bunch of different doors at once, connecting all these weird, unrelated cosmic mysteries.
Look, here's why this matters. This is the takeaway. It's not just one thing. This single idea potentially solves that crazy fine-tuning problem. It gives us a real physical story for what happened at the Big Bang. It explains these weird patterns we're actually seeing in the sky. And most importantly, it makes predictions we can go out and test. This is real science.
And that leaves us with one last, truly mind-bending thought to chew on. If our universe really was born inside a black hole from a parent universe, then what's that parent universe like? And does it have black holes that are right now giving birth to even more universes? It makes you wonder, we might just be one link in a vast and maybe even infinite cosmic chain.